Hello, and welcome back to this series on recreating Baldur's Gate 3's camera system in Unreal Engine. In the last episode, we managed to get this destination marker up and running so we can visualize where we're sending our character. And, while not directly useful or not directly related to the camera system, it's going to be very handy for this episode when we start adding in more environment that can start getting in the way of the camera and the character. Now, in Baldur's Gate 3, one of the key features of the system is that you're always able to see your character no matter how many objects or environments or walls are in the way. You can always have a clear line of sight to the character. And that's what this episode is going to be on. We're going to start making the materials, or more specifically the material functions, that allow us to mask out the environment and create holes in them and, mess with the transparency of the environment. So, to preface this, I will specify that I am not a technical artist by any means. Everything I'm about to show you here I have learned specifically for this. So, things might not be as efficient as possible. If you know of any better ways I can achieve any of these effects, please let me know, because I'm as eager to learn all of this as you are. But without further ado, here we are with the camera system. Materials. So we're going to go to Content, Materials, and we're going to create, first of all, a new material function. Now, we can go down to Material, create a material function, and I'm going to call this mf_environment mask. A material function is very similar to its blueprint function counterpart. It's a repeatable chunk of logic you can reuse over and over in multiple places, and it'll give you the same effect. The benefit of this is that because we're going to be using this in multiple materials, we only have to edit the logic for it in this one place for it to apply to all the materials we're using it in. So it's just a very quick reusable piece of logic. So we can open that up, and you will notice straight away that it does not exactly look like the material graph. It's very similar, but it doesn't have, if I load up the destination marker, it doesn't have this big master node at the end. It has just a single output result, and that's what we're going to be plugging in our logic, because this is going to hook up inside a material graph itself. So I'm going to, first of all, make a material that we can start visualizing things with. I'm going to go Material, and I'm going to call this mm_environment, something basic like that. I'm just going to be using this one material for this tutorial, but when it comes time for you to start applying this to your own environment, just make sure you're applying all of this logic to each of the materials you need to get this working for your environment. So I'm going to load up this material, and I'm going to start plugging in just some base values so we can have a bit of color and, a basic thing to look at. I'm going to hold down 3 and left click to get a vector 3. And let's make this kind of like a wood color. So I'm going to make this quite brown. Something like that. And I'm going to hold down 1 and left click in empty space to get a scalar value. Plug that into metallic. And again for roughness. And I'm going to change the metallic to 0.2 and the roughness to 0.8. And now we've got the material, we need to start being able to mess with its transparency. But one thing you'll notice is that in the master node itself, opacity and opacity mask are currently grayed out. We don't have access to them right now. That's because the materials blend mode, if you left click just an empty space, you can get the details panel up here. You will see its blend mode is set to opaque, so it can't have opacity. Now, there's two ways we can get opacity with this. We can go translucent, or we can go masked. If you've worked in materials before, you might be used to translucent, because this is your standard way of getting transparency in an object. It goes from 0 to 1, 0 being completely transparent to 1 being completely opaque, and any value in between is going to give you a shade of translucency. However, that is very expensive, especially for something that we're going to be applying on, pretty much every material in our scene. So we can go for a much cheaper version. We can go masked. Masked is very similar to translucency, however, it is only 0 or only 1, meaning that it's either completely transparent or completely opaque. And that's a lot less expensive to calculate on the rendering stage. So we can make it masked, and that opens up the opacity mask, which we can now plug in our environment mask into. So if we right click and go environment, it's not showing up because we didn't set this to be exposed. The thing you'll need to do is open up the material function and get the details panel and expose to library. Just make sure that's ticked. That'll allow us to start plugging it into materials. So apply and save that. Come back to the material, and there we go. It starts showing up. So now we can plug environment mask into the opacity mask to start controlling the transparency of this material. And there we go. And we're getting an error just because in the material function we've got nothing hooked up to the output result. I'm just going to put a scalar value in, holding down 1 and left clicking. And we're going to set this to 1 for the time being, so it's completely opaque and we can, properly see what we're doing with this material. So that clears up the error. We can apply and save. And now let's start building up a basic environment here. So I'm going to throw down a few cubes and apply the material that we made to it. And we'll speed this up and get talking about it in a bit. So okay, now we've got a fairly basic and ugly looking environment here, and we can start using this to visualize the effects that we're getting on the material. The first thing that we need to do for getting this masked effect around the character is figuring out which pixels are going to be between the camera and the character, which environment objects are between. So the thing that we need to do is load up the material function and do something very similar to what we did on the cleanup or the polish stage for the camera movement. We're going to be using the dot product again. So we want to find the direction from the camera to the character and compare that to the direction from the camera to a rendered pixel on the screen. And by that I mean the world position of whatever pixel is being rendered. So we can get those three values by doing camera position world space, camera position WS, world position, which gives us the world position of whatever pixel is trying to be rendered. And by that what I mean is if I hit play here, we're trying to find out what the world position of each of these pixels on the screen is being rendered at, and we're going to be comparing each of those to the direction from the camera to the character. So for this instance, we want to be finding these pixels, right? So what we also need is the player location. Now we don't have an easy way to get the player location yet. What we can do though is we can come back to the content browser, right click, go to material, and make a material parameter collection. Now this is just a storage sort of object that stores values that can be referenced by materials. And we can call this something fairly generic like BG3. Let's just go parameter collection, right? Something fairly basic. And what we want to store in here is the player's location. So we can go vector parameters, add a new one, open that up, and parameter name, we're going to change to player location. Now what you'll notice is it is a linear color struct. It is a color rather than a standard vector you're probably used to when you're using the actor location or any vector kind of maths. And that's fine. We can convert a vector to a linear struct. You'll notice that the linear struct has 4 values here, R, G, B, and A. These are going to correlate to X, Y, and Z, and we can just ignore the A here. So X is R, Y is G, and Z is B. Keep that in mind. And what we want to do is we want to be setting this value every frame. We want to be updating where the player is. And we can do that inside the player blueprint. So if we come down to content, third person character, we can get the event tick because we want this to be happening every frame. And dragging off from that, we can do set vector parameter value. And it should be under rendering material, and you've got a few here, but it's just the basic one, set vector parameter material or value. And you'll notice that it comes up with a collection node and a parameter node and value. We can choose the parameter collection that we just created, and it should populate the parameter name with the list of possible things we can set. And because the only one we can set is player location, we can choose that. And now, how do we get the player's location? Well, very simply, get actor location. And you might be worrying, this is a vector node and this is a linear struct, but as I said, you can just drag that in and it'll automatically convert the XYZ to the RGB values. So compile and save that. And now we can come back to our environment mask, right click and go parameter or collection parameter. Yeah, there we go. And it'll come in unspecified, but we can change that to, again, BG3 parameter collection and player location. And now we have the player location. However, it is coming in as RGBA, remember, because we're using a linear struct. So we want to get rid of that alpha value. So we can drag out again, get a component mask, and set that to RG and B. So now we're getting the X, Y, and Z values only. It is a vector 3, similar with the world position and the camera position. And now we can start doing some maths. So what do we need to do? We need to get the dot product of the directions of the camera position to the player location and the camera position to the world position of each pixel, right? So what we can do is drag out from here and do subtract. And I'm going to drag out from world position and do subtract as well. And into each of the B values, I'm going to plug in camera position. And this is giving us a directional vector with values that are a bit too high for what we need. So we can normalize this to get a unit direction vector. Normalize. And a unit direction vector is just a vector with the values between 0 and 1. So it is an absolute direction. And now that we've got these, we can do the dot product. Get these two values, plug that in. And what this should be now telling us is what pixels are between the camera and the player. So we can try and visualize this. If we plug this now into the output results, see what we get. Apply and save. One thing before we test this out, what I will mention is that, as I said before, a masked material gives you either a 0 or a 1. However, this dot product is going to give us values between -1 and 1. It's going to be a range of values, not just 0 or 1. So what we first of all need to do, actually, is clamp this value to 0 to 1, because we don't care about anything in the other direction, i.e. the negative values. Apply and save that. And in the material node, one thing that's important to note is if you search mask, you'll find the opacity mask clip value. Now this is set to 0.3333, and what this is doing is it's saying whatever is under this value, make it 0, whatever's above it, make it 1. So if it's below this value, it's going to be transparent. If it's above this value, it's going to be opaque. Now we might adjust this later. It's just something I want to bring up now in case I forget to and in case it's useful for you, but we're not going to get into it right yet. We're going to first of all test and see if this is working. So it's definitely doing something. You can see that it's cutting out some of these walls now as we're flying around. And the problem with it is it's currently getting all the values between the camera and the player and setting those as 1 rather than as 0. So what we need to do is come back to the material function, and after this clamp or before this clamp? I'm going to go after or before. I'm going to go 1 minus just to invert these values. Clamp that, apply and save. And now we should see something that looks like this. We've got a white exterior and a black interior. This black is going to be our transparent area. And already you'll see that pretty much everything masks out because the radius is currently too big, but that is already looking a lot better, right? So what we need to do now is control that radius. This is way too large for us. What we can do now is, now that we've got that clamped value, I'm actually going to do all this logic before the clamp. I am going to divide this value by a scalar parameter. So hold down 1 and left click to get this, and make sure the value is not 0 because we don't want to divide by 0. I'm going to set it as 1 for now so it doesn't do anything. I'm also going to right click and convert to parameter so we can adjust this in real time. And I'm going to go occlusion size, something like that. And let's start adjusting this value. I'm actually going to apply and save first. Let's see what happens if we up it to maybe 2. Let the shaders compile first of all. So I think we went in the other direction here. I think we want to actually go smaller. Let's try 0.2. You'll notice in the preview node it's getting a lot clearer on the definition of that black circle. And there we go, that's much nicer. So now we are masking out everything in a much tighter radius around the character. However, we don't really have any depth of field in this. So what we can also do to really just hammer home that effect is we can, I'm going to do this before the occlusion size. I am going to multiply, I'm going to plug that into the B rather than the A, this by the pixel depth. Now the pixel depth is how far away the pixel is from the camera. So this should start giving us a, once the material or shaders compile, we should start seeing this. It should give us a kind of gradual effect going through this material. If we hit play. So we might need to up that occlusion size now, as that's very small. So let's do that real quick. Let's change that from 0.2 to, we might need to up this way more actually. Let's try 20 actually, now that we're also taking into consideration the pixel depth. There we go, that's much nicer. So now you see that it's got a gradual fall off on each of these objects. So we can kind of get a sense of how many objects are between the camera and the player. And I'm going to up that value just a bit more so it's a little larger. Let's go, I'm doing this on the other screen, sorry. I'm going to up that to 40. And if we hit play, I'm hitting Alt-P to play, by the way, as a shortcut. And that's getting there. I'm going to leave that there for now, and we might adjust this later on, but that is starting to mask out the location between the camera and the character. And if we start moving that character around, you'll notice that the masking moves with it. And we can visualize that through pretty much everything here. So that is awesome. In the next episode, we're going to be refining this a bit more. We're going to add noise into the outer regions of this radius and just start cleaning it up a bit. We've got some logic to do also on, you'll notice it's also masking out areas behind the character. We want to stop that, so that's going to be in the next episode. So I will see you there. Hopefully you've learned something here, and yeah, if you've got any comments, leave them down below.